Hello and welcome to our presentation from our master project. We were three students, Jens Jendrisek, Christian Fuchs, and me, Benedikt Müller, which developed Argos. So we are master students at Westfälische Hochschule Buhr. As part of our master degree in internet security, we took the master project module. In this module, we worked on provenance graphs and developed Argos within one semester. This development is set to continue in the coming winter semester. The requirements for the master's project were as follows: integration of Camflow into a system, visual representation of the provenance graph of Camflow. In this video, we would like to demonstrate the software and show our progress after one semester. We would like to give a brief overview of the technologies we have used, which we intend to build on in the coming winter semester. A brief insight into provenance graphs, and also this video should show you how complex IT systems are. Provenance and abstract layer. Before we go into the front end, I want to show you that we have two different types of layers: the provenance layer and the abstract layer. The provenance layer is based on, so even the abstract layer is based on the Camflow data traced, but the provenance layer is a representation of the provenance graph. So all nodes and all edges were represented in the specific layer. So you have a full visualization of the provenance graph. But a full visualization means that it's very, very complex and it's very hard to read. Therefore, we're introducing the abstract layer. The abstract layer is based on finding communities in the provenance layers through the graph network and extract different types of attributes out of communities within this provenance layer and creating new objects for the abstract layer. Therefore, we have a smaller graph with the same information as the provenance layer, but you can read it, hopefully. We will see. We will see it in a few seconds in front end, and you can have your own. You can have your own opinion about this abstract layer, and hopefully you have a better understanding on what is going on the operating system. Firstly, we will check our configuration, which is on this device we're on about. And we have a virtual machine running on this device with Fedora 36. Camflow, unfortunately, was not updating since 3 years. So we tried to patch a kernel with Camflow on Fedora 42, but time-wise, it didn't work, and time-wise we switched to Fedora 36 because in the documentation it says that it is working on Fedora 36, and yeah, we can see it is working. And on the left we have a terminal which with SSR communication to the specific virtual machine. So like I said, the virtual machine is also running on this device. And next, I want to give you my Camflow configuration. I do not track any groups or users, and also I do not track any ports or IP specifically for this demonstration because of the big data. We only track some kind of files to have a small provenance graph and see what is going on the IT system. And perhaps this is also the way to do it. We will see in the research in the future. And next step, I want to show you the configuration of the daemon. So we are using as the output, the W3C format from so the standard format. Camflow is creating documents, and therefore we using the MQTT protocol for sending those documents to the port 1883. This is specifically the broker, the MQTT broker, as a container, and our backend, our Spring Boot backend, also is connected via MQTT to this broker and becomes the documents, parsing those documents, and saving it in the Neo4j database. Okay. Next step, we will execute one file, I think. Yeah, let's do this one. Hello World 2. And we go to the front end. Okay, so now we are on the front end. The front end is based on React. The graph visualization is based on React Flow. On the top, we have the navigation bar, Argos. We have a sort button to sort this graph. Always the machine is on the top. Then there comes the processes, and then there come files or process memories. We have a reconnect button for the WebSocket. So we're using a WebSocket connection between the front end and the Spring Boot backend. So it's backend streaming the graph, the provenance graph data to the front end if there's new data to stream. We have a toggle button for the different layers, the abstract layer and the provenance layer. So if we click on the provenance, here is it. Okay, so yeah, here's the provenance layer. We can sort it and we can see the whole provenance graph. But I really do like the abstract one. But this is perhaps something that we need to fix. Okay, but here's the abstract provenance graph. Okay, and also we sort it. Okay, so next step, we can download this specific graph and we can upload our own JSON, so our own provenance graph. But be patient. The backend, so both WebSockets for the abstract and the provenance layer, the JSON which is streaming, which the backend streams, has a custom format for React Flow. So the front end has not much work to convert the JSON for React Flow. Okay, so perhaps you download if you want to execute this software application. You can perhaps download a JSON file, or we can show you the JSON format, and you have an example of what the example or of what the JSON file should look like. Next, we have the node numbers and the edge numbers, so we can see the difference between the abstract and the provenance layer and the connection status. So we go further. I think we can check up now the information about nodes and relations. So we now have the node machine of type machine. We have one machine. This is a Linux machine, which we are on about at the terminal. And we have here more information on the history. We have more information about the specific machine. So we have the name of this machine. We have the operating system, which is called. We have the kernel version. So you can see that the kernel is patched. Also, we can see the architecture of this, mostly of my device, and the type. On this machine, there was running a process. So a task represents a running process in the system. And this process has also more detailed information. So perhaps we can use this process ID for more information at the OTD. Perhaps in the combination with the timestamp. Yeah, so this is very useful, we think, perhaps in the future. Next step, we can check that this process has a relation to print2.py. This inode file is in the opt folder, and there were different relations between those tools. We can check the history, so we see that they were getting attribute, open it, a permission check were done, and also another get attributes from the specific process. We have the process memory, which is assigned to the specific process, so the virtual memory address, the virtual memory area. And also here we have more information about the process memory. And we can see an inode file. Typically, it's a cache because the process memory typically communicates with the cache. And perhaps we will see it in the future when we execute another one. But Camflow did not capture this path yet. Perhaps I can show you also the Neo4j database. So this is how it's looking in the Neo4j database. We have activities, we have entities, agents, like in the W3C standard document or defined. And on the right side, we have the abstract graph. Okay, so now I would say we execute another file. One second. Ah, yeah. Okay, so this one brings us the Fibonacci numbers. So just let's do this. So now we know that on position 51, the Fibonacci number is whatever. And another one would be print 1. So we should have now around about 3 processes and yeah, 3 files. So let's check. We have 3 processes and 3 files. So print 2, print 1, and calc.py. Each process has its own process memory with we can see now that the cache file is now here. So every process memory was communicating to the specific cache, and you can see what the process memory did. It was always a read. We can see it, and yeah, this is fine. Okay, so we can now, let's say, doing something like ls minus la, and we also want to do ls, and we also do want to do top, and want to check up all the processes which are running on this, or not processes, even daemons, which are running on this machine. And yeah, so we can see that the sort algorithm is not by default. It's an idea to do that. Yeah, so the graph always is building up new. Just one semester. So we did not have so much time for for usability, I think. So the functionality was the heavier part. But you can see you can see something is going on here. So we have an unknown task with the inode file, and you can see here 2 process memories with ls. And when we check the details, you can see some arguments even. So ls and minus la, and yeah, so there was more going on. Also, there was color auto. I think this is automatically, but we don't see this in the terminal. Here's the second LA, but it sorry, LS, but only with LS, not with LA. And what we can else we can see, here we can see top. I think, yeah, see that the backend is starting the abstract layer now, and perhaps in a few seconds we can see that this top process memory or even node file will be connected to the Linux, but because the process is missing here. Typically, I mean, it can happen that Camflow is not tracing this, or yeah, something is missing, but mostly this should not happen. Okay. Um, yeah. So what else can I say? Yeah, I can say, or I can show you, or we can wait a second because the abstract layer is now done, but the broadcast didn't spread, so the graph was not ha or had no any what's calling any changes. But we can go now to the provenance layer, I think, and I want to show you the provenance layer. So we see now that there are much more edges and nodes. Okay, so I sort this now, and you can see that when we go to the right side, that there's really much going on. Yeah. So we have two agents. The agents are on the abstract layer, the machine, based on the type. So you have here even more information. Um, you have okay, I see. The graph was creating new. Let's go back to the graph. I, I can show you this in a second. Here. Oh, sorry. I was I was wrong. That's a coordination. Um, so I just want to show you that it's really hard to understand what's going on. Okay. So I just want to stop the backend real quick because I want to show you this, and the front end is always missing the sort. Okay. So you can see that on this specific graph now, we have many nodes. Yeah. So these are really many nodes. And um, it's really hard to understand what is going on now because the entities doesn't have any label on it. Okay, so there is a prof label. Um, so perhaps we could use this label, but it's difficult the because there are so many edges and nodes, and the complexity of this graph is so big. Um, Even when you trace like a SSH daemon, it's going so big, and therefore we use the abstract layer to have a better overview of what is going on the machine, and to have a better yeah, to have a better understanding of what is going on. And lastly, I want to show you yeah the graphs in the Neo4j database. So we have here where my mouse is, all over the provenance layer. Okay, provenance layer, and what is here? This is the abstract layer. Okay, and I think you get the feeling of of how big provenance data can be. And honestly, we did not really much. Okay, so we did just some execution, and so it's a good question to ask. Um, what should you trace? What should you trace on a real productive environment? Okay, this is the question. And we also have more questions for the winter semester. So I would say we dive directly into the last one. So um, services or yeah. So what do we want in the winter semester? So services or programs are solutions to problems that are solved on an IT system. So the question is, can we derive static rules for the behavior of an IT system from this? Can we rely on past attack patterns for attack detection? This is also a question we have because we don't think so. Also, we don't think so that we can rely on past attacks, and we should not trust in this past attacks. We should know what is the normal behavior of our IT systems. And the third question is why is normal program behavior not defined? These questions reflect fundamental challenges in security research and motivate our conceptual further development of Argos. So, like I tried to explain, our Argos development in this only one semester is just the basic idea what we have. And we want to bring this further. We want to bring this further in the winter semester. We want to do further research, and develop further the software, and and also do a better performance on the software, because and really know what we should trace, what is important to trace. Okay, this is our goal for the winter semester. And I hope Professor Dr. Christian Dietrich will help us again. And so this was the video. I hope you have a good understanding of Argos now, and know what we did in the past summer semester. And I wish you a great day or evening.